In this video, I will present the definitions of recovery, rehabilitation, and reconstruction, and a few examples of science and technology for recovery in general. To better understand the recovery, rehabilitation, and reconstruction definitions, let us first look at examples of capital assets. The building blocks of a livelihood, or capital assets, include human capital, such as knowledge, skills, and experience, natural capital, natural resources and ecosystems, financial capital, such as credits, savings, and insurance. The capacity to maintain or recover these capital assets defines the impact of a disaster on livelihoods. Recovery includes the decisions and actions aimed at restoring or improving livelihoods, health, as well as economic, physical, social, cultural, and environmental assets, systems, and activities of a disaster-affected community or society, aligning with the principles of sustainable development, including build back better to avoid or reduce future disaster risk. Rehabilitation is the rapid and basic restoration of services and facilities for the functioning of a community or a society affected by disaster. Reconstruction is the medium and long-term repair and sustainable restoration of critical infrastructures, services, housing, facilities, and livelihoods required for the full functioning of a community or society affected by disaster. In the early phases of recovery, the rehabilitation, the cluster approach presented earlier in the course is also used. Recovery should include addressing all the capital assets that you see, for example, health, nutrition, shelter, etc. During recovery, it is important to target the social and economic sectors that need the most help. For this, it is essential that sociocultural factors are present in all assessment tools. There is equal representation and participation of minorities, and cultural sensitive tools, technologies, and materials should be used. Science and technology are essential in helping obtain information on livelihoods through livelihood assessments. For example, through the development and use of baseline information and analysis, the use of empirical evidence, and the understanding of impacts. In addition to the use of science and technology during assessments, other examples of science and technology for recovery include the use of software and computers for education and skill development, mangrove fauna cultivation, and small-scale agriculture. Both the education and sustainable economic activities can help those affected regain their sources of income. Other examples include alternative energy technology, when moving back from temporary shelters to their communities, and sanitation systems and stormwater management systems. Other technologies being used and that have been emerging for the recovery phase include 3D printers, biometric scanners, real-time translation that can help psychology professionals access more people in need of support services. Furthermore, EPFL and ICRC have been further developing orthopedic feet, increasing the level of agility for the person wearing it. In addition to a variety of recovery science and technology examples, we saw that the capacity to maintain or recover capital assets defines the impact of a disaster on livelihoods. We also saw that science and technology are essential in helping obtain information on livelihoods, and that several sciences and technologies can help in the recovery of those livelihoods.